Hello and welcome to Slooh, where educators and parents bring live astronomy into their classrooms and home schools to inspire and engage their students in the study of space and earth sciences. We also have a burgeoning community of astronomy enthusiasts from around the globe. Now, students and members use Slooh's live telescopes in the Canary Islands, Chile, and our Australian observatories to capture images of celestial objects they use in our unique curriculum-aligned Quest learning activities, which we'll look at later. And now, students can actually peer back at Earth using orbiting satellites and our Earth science learning activities to study our home planet, to study geology, geography, and environmental science. Tonight, though, we've got some terrific live feeds from partners around the globe that we're going to be talking to later. And we also have images streaming in from Slooh's half-meter telescope in Australia to watch a spectacular lunar event. It's a blood moon total lunar eclipse, one of our favorite events here at Slooh. Now, huge thanks to all of our feed partners tonight, some of whom have been struggling with weather and all manner of technical glitches, but we've already got some fabulous live views up on the screen. And thanks too to Gretchen Bickett, who's running the Star Party tonight and brought all of this together for us all. Now, I'm Paul Cox, your host today, and together with our expert and special guest tonight, well, it's tonight for me, it's probably midday for a lot of you, we're going to be learning about the moon and lunar eclipses. We also have some exciting news about a new competition, the Falling for the Moon contest. More details later, but you can read more about that in our September newsletter that can be found on our website. You just go to the homepage of Slooh, www.slooh.com, scroll to the bottom of the homepage and select our blog. Now then, before we welcome our first guest, we've got some other exciting news about a new way for educators and parents to begin their students' journey of exploration and discovery of the universe with our new school and homeschool starter memberships. Those are going to be launching on September 15th, so keep your eyes peeled for those. Now, these new accounts, they provide a really easy opportunity to give your students a taste of the universe without a full year commitment. So it's ideal for educators running only a single astronomy unit. Now, like all Slooh's accounts, they include live telescope views and control and guided learning activities, those quests that I was talking to you about, all at a starter price. It really is your starter pass to the cosmos. So check those out on September 15th because it's going to open up the universe to so many more students. Now, before I invite our first guest on, let's take a quick step through the live feeds that we've got. Now, we were hoping to have a feed from the Gravity Discovery Centre and Observatory in Western Australia, but Rick Tonello down there, he's been running around all over the place, jumping in his car, trying to find a little bit of clear sky to no avail. But we're still going to be talking to Rick a little bit later about the work of the Gravity Discovery Centre and Observatory down there, because they do some marvelous outreach work, totally aligned to Slooh's mission. We've also got Yatni as well at the Observatorium Boscha, and that's where this live feed is coming from at the moment. They're at the Institute of Technology Bandung, Indonesia. And they've had we've been watching this feed for nearly an hour now, and it really has been spectacular. And our friends at the Astronomical Society of India have also been fighting off cloud and rain, but they persisted, and we've seen a couple of views from them. So we'll keep an eye on that. But starting a little bit later, because the moon hasn't risen in Europe, but starting a little later, when that eclipsed moon is rising in Europe, we'll have a feed from long-time Slooh member Jari Backman, who is in Finland. So we're looking forward to that. That's going to be about an hour, something like that. Now then, snapping images. Don't forget, Slooh members can snap images from our live feeds tonight. Just go to the Star Party page. We might be able to show this on the screen. Here you go. Go to the, you might need to refresh that. But you go to the Live Star Party page, here we go. And all you have to do is click on the feeds. Now, unfortunately, Australia is weathered out. But if you go to that page, if you then scroll down, you should see a snap. You should see the camera icon, maybe. So there it is. You just click that button, just like all of Slooh's live telescope feeds. And there you go. Let's click on that image that you just snapped. And there it is. So that is going to be available to you in your My Photos, including the new quest, the Moments quest for this eclipse that we've got. And we're going to show you that a little bit later as well. Now then, I think actually there's another quest which is really cool. I wonder if any students watching are going to use this. It's our quest animation tool quest. Now, if you take a series of snaps from this Indonesia feed, you need to do it all from the same feed. You could use that quest animation tool and actually turn it into an animation. So all of the images that you capture could turn it into a time-lapse animation to show the entire quest. Now, that's what we're going to see, but what are we going to learn about and discuss with our special guests? Well, we have got Slooh educators, Keith Wozaleski, Milton Villarol. They run our space science classes in English and Spanish. They're going to be giving us an Eclipse 101, explaining the peculiar phenomena of lunar libration, a whole bunch of other lunar features and phenomena. And Milton is going to be sharing some lunar mythology and telling us what archaeoastronomy is. That is, make sure you capture that, because we are dealing with a lot of culture tonight and mythology and how events like this have been seen down the ages by various cultures. And that's where our two other guests come in. Rick Tonello and Yatni from Indonesia. They're going to be joining us live from Australia and Indonesia to tell us about their respective outreach work and to discuss how lunar eclipses have been perceived in their parts of the world down the ages. Now, don't forget, Slooh members can join us in Zoom to ask questions throughout the event. We'll try and get to all of those. We'll also have a good opportunity at the end as well to be able to do that. So we've got plenty to look forward to. So let's get started and welcome my first guest, Slooh educator Keith Wozaleski, for a Lunar Eclipse 101. Hello, Keith. Can you hear me?
Yes, hello, Paul. Thank you for having me. What a big event. One of my favorite celestial events, a total lunar eclipse. Wow.
It is, and we share that. We kind of love a lunar eclipse event. And for me, it's because the length of a lunar eclipse is far, far longer than the kind of total phase of a solar eclipse. But why do you love a lunar eclipse so much, Keith?
I like them because they're nice, long, drawn-out, casual events. It's not like totality with a solar eclipse where you have to be in a certain spot and it's only going to last for a few minutes. This will last for well over an hour for totality with us. So if you need to go inside, take a break, you can. It's just a nice, casual way, and especially if you're with other people, you can talk, you can
Yeah,
enjoy the event without, holding your breath to wait for it to happen.
exactly. So a lunar eclipse 101. Here we can see the full moon because it's full moon tonight. It's a full corn moon, but it doesn't look like a full moon. So, what happens to the moon during this lunar eclipse, and why are we seeing the live images like this, Keith?
Well, we are seeing the eclipse already underway. When we have an eclipse, any type of eclipse, we have three main players. We have the sun and the earth. And because the sun is a very bright light source in the center of the solar system, when it shines on a planet like the earth, it is casting a shadow. And here we see our lunar eclipse diagram. The Earth actually casts two types of shadows. We have this very faint outer shadow that we call the penumbra. And we've already missed most of the penumbral part of the eclipse. That's where the eclipse actually begins. There's not a whole lot to see, so that's kind of why we started later. The penumbral shadow is very, very faint, very dim, and because the moon is so bright, we don't really see a darkening of the moon, certainly not in real life and with the naked eye. The eye gathers so much light. You really need to have something like the Slooh telescopes to see that slight darkening. As the moon makes its way around the Earth in its counterclockwise orbit, it will move into the darker shadow, the umbra. That's the central shadow, which is where we are now. We're more than halfway into the umbral shadow. The moon will continue and it will reach the point where it's completely enveloped by the umbra shadow. and that will be the moment of totality. It's also the moment where we are at full moon, the moment of total maximum eclipse. We're not actually quite at full moon. We're very, very close to it. The full moon is a moment in time, and that a moment in time is going to coincide with the moment of maximum totality. So we're getting there. We'll be there in about 20 minutes.
We are. Keith, one of the things I want to point out about that lovely diagram that you put together is that image of the sun on the left. Obviously, this is not to scale, but tell us where you got that image of the sun from.
This is actually from Dr. John put this slide together for one of the lunar eclipse quests. This sun is a live image from the Canary 5 solar telescope. So we now have, if you haven't looked at the solar telescope in a while, we have a full disk image of the sun. And we've got, it looks like some chromosphere activity. We see some granulation. So it's an image right from the Slooh telescopes.
Excellent. I love that. So, what we're seeing here then, if we go back to, well, we won't go back to that diagram, but we looked at that diagram and we're seeing the the Earth shadow basically starting to cover the moon like this. What can that tell us about our own planet? Is there anything that I'm thinking that there are some conspiracy theories around, aren't there, that this kind of disproves?
Yeah, the Greek astronomers understood that the Earth was also circular, just like the disk of the sun and of the Earth. And one of the ways they proved this was by looking at what we have here, a lunar eclipse. We can definitely see the curve of the Earth, and of course, the Earth casts a huge shadow, so we see it's much larger than the moon, but you can definitely make out the curve. It
Yeah.
was a little sharper before, so there's some atmosphere at play here, but you can definitely see the curve, even though it is kind of feathery. It's a soft edge. But yeah, we can see it. And not just that, we know from lunar astronauts where they've said, look, I can confirm that the Earth is in fact round. So yeah, there is no
Exactly.
flat Earth here.
Yeah.
It's pretty
There is
clear.
no flat Earth. There is no flat Earth. Now, if we can just hop back to that diagram a second, because Keith, you said that, this is the moon is passing into Earth's shadow. So if the Earth is between the sun and the moon, why don't we get a lunar eclipse every single month, every time there's a full moon?
Yeah, it would seem that we would, right? Because we have a full moon every month. But the problem is that the moon has an orbit that's about 5 degrees tilted from the line between the Earth and the sun. So if we drew a line, a plane between the Earth and the sun, the moon has to be within that plane. That only happens once every 6 months. So if we go ahead, rush into slide 3, we have a little video animation that shows orbit of the moon around the Earth. So here we have an overhead view. The moon is making its way. The moon also casts a shadow, but we need to pass into the shadow of the Earth to have the eclipse condition met. But the moon isn't always in that line between the Earth and the
Aha.
sun. So sometimes
Right.
it's below, sometimes it's above, and the moon kind of wobbles like a plate around the Earth. We need to have it at a point where it is exactly in that center line, and that's when we have an eclipse. Like I said, the eclipse season about every 6 months, minus a few days, we will have another lunar eclipse. I have some still diagrams here. Yeah, so the moon a lot of times is above, below the orbit or of the Earth, and sometimes it's above that plane. It needs to be exactly in that plane. I want to look at this slide for a minute or two. Where the moon is relative to that line drawn between the Earth and the sun will determine one, if we even have an eclipse. It will determine two, what type of eclipse we have. Today we're having a total lunar eclipse. We could also just have a penumbral eclipse where it never passes into the darker shadow. Sometimes we get a partial eclipse where it's in between the penumbral and the umbral shadow. The neat thing about this is if we notice, since the moon is well placed during a total lunar eclipse, it will be followed by a solar eclipse of some type in 2 weeks when we have the new moon. This time it will be a partial solar eclipse. It's even possible for there to be a third eclipse in that eclipse cycle, in that eclipse season, where you could conceivably have a third eclipse, which would be another lunar eclipse of some type. We are going to get the partial in 2 weeks. We're not getting the the third eclipse, and we can expect to see this every 6 months or so. So
Okay.
uh, it's something that we look forward to. And like I said, they go backwards. It's every 6 months minus a few days. So we're at
Yeah.
September now. I think the next lunar eclipse will be in March or the end of February 2026.
And just like so many events in our solar system, it's kind of clockwork. And, this is what we're going to be talking about a little bit later as well. The ancients were able to start forecasting these events. But the solar eclipse, as you say, always comes with a lunar eclipse 2 weeks before or 2 weeks after. We did go through a little bit of a dearth, didn't we, of not having a total lunar eclipse, what's sometimes called a blood moon eclipse. I think most of a year, and then we've had two, I believe, this year because we had the blood moon eclipse in March as well.
Yeah, we've been on a pretty good run. And again, it has to do with the fact that we have the elliptical orbit of the moon around the Earth. It takes 29 and a half days for the moon to go through its cycle of phases as viewed from Earth. So there are a lot of variables. So yeah, you have that possibility where you're never quite in that exact position that we need to be in, at that arrangement of the sun, Earth, moon, to be in that penumbra, that umbral shadow like we have tonight.
Excellent. Now, Keith, we're going to start talking about the phases of an eclipse. We've hinted at a few of those and some of the phenomena that we're going to see. But let's do a little recap. If Slooh members are watching, if you want to know how you can capture these images, Gretchen, I don't know if you can, I caught you off guard there probably, but if we could go back to that page. So here we go. We can go to that particular feed. So there we are on Indonesia, and you just hop down. So this is the event page. So if you're a Slooh member, you're watching on the event page rather than YouTube or social media, and you can come into the event page, go up to the top of that page, and you'll see the two feeds. Unfortunately, Australia is offline at the moment, but hit Indonesia, and then you hop down, click that camera icon, and that image is going to be available for you for your quest, our special moments quest that we're going to be talking about later as well. So, Keith, this is a really good opportunity now, I think. Um, by the way, Gretchen, maybe update this feed because it might be lagging behind a little. There you go. So we've got some color here, Keith. So this is a great opportunity, a great segue into talking about the phases of an eclipse. What are the different phases of a lunar eclipse, and which phase are we currently in? Because the eclipse actually started quite a long time ago, and I think you hinted that those initial phases can be quite difficult to see, um, but we can very obviously see some changes now.
Yes, we were already past pretty much the beginning of the penumbral stage, and we're into the umbral stage where the moon is passing through that umbral shadow. And when we chose a time for this event, I ran some simulations in Solarium, and uh, I knew that if we got to about this point, we were going to start to see some color. We're going to talk about color as we go on, but that color will darken as we move further and deeper into the umbral shadow. So we're already into that, what they would call the second contact of being in that umbral shadow. The next point is going to be totality, which is in about 10 minutes. And as we move into that total phase, we will see the moon darken as it moves into into the Earth's shadow more and more, and we will lose that bright portion that we see in the 9, 8, 7 o'clock position. That bright part will become enveloped as it moves further and deeper into the shadows. So we are well on our way. We're about three-quarters of the way.
I I I do love this stage of an eclipse, and it's when we see, and this is so difficult. So our feed partners, it's actually quite difficult because what we saw before was a shadow, and we could still see some of the fully illuminated um, surface of the moon. But this has to do with exposure duration. So during an eclipse, they have to change the exposure duration. that their cameras are taking, a video camera in this particular case. And it's a really difficult judgment because here to show the color in Indonesia, they've had to overexpose the other part of the moon. So it's a really challenging task, isn't it?
I've always said the time to learn how to take images of a lunar eclipse live is not the moment of the eclipse because you are doing exactly as you said. You're playing around with aperture and exposure and all kinds of
Yeah.
things, all kinds of variables. This is a difficult shot to get both, where you've got the lunar detail, the color starting to come in, and you have to choose to overexpose the other limb. Exactly right.
Yeah.
Yeah, this is tough. This is tough to do.
It is.
Fantastic.
Well, one of the things I love about seeing different feeds coming in as well is some of the differences in color that we see in a blood moon total lunar eclipse is due to the camera setup and all of the other equipment that they're using. But it also has to do with the altitude of the moon from that particular observing position, so how much atmosphere we're looking through. But it's also a good indicator of the atmospheric conditions over any particular part of the world as well. And we have seen over the years on Slooh some of the deepest red blood moon eclipses when there's been a lot of wildfires around. So what's going on there, Keith?
You are exactly, you said it all, Paul. That's exactly it. It's a function, first of all, of the passage of light through the Earth's atmosphere. That's what gives it that fundamental reddish color, something that we call Rayleigh scattering. We're going to talk about this later, but you brought it up, so let's talk about it now. The As light passes from the sun, don't forget the sun. If you think of a child's drawing, they usually color the sun yellow. The sun is not yellow; it's white. It emits white light, which contains all the colors of the spectrum. And as it passes through the atmosphere acts like a lens. It will scatter the shorter wavelengths of light, the blue, indigo, violet, out into space. That's what gives our sky the blue color. And it will bend the longer wavelengths of light, the red, orange, yellow, around the Earth. And that's what's reflecting off the moon fundamentally. But you're absolutely right. Depending on where the moon is, we've all seen full moons rise and set where they are glow this beautiful orange color. That's because of atmospheric conditions where we live on Earth. It is a great indicator of the health of the atmosphere on Earth. Like you said, wildfires contribute, volcanic eruptions also work. Any type of debris that's spewed out into the atmosphere, pollutants, and that doesn't always mean man-made pollutants. There are pollutants that are naturally occurring, like you said,
Yeah.
wildfires, smoke, stuff coming from volcanic eruptions, whatever else, as that's floating
Mm,
out in the atmosphere, that also refracts light and filters the light in the same way that a lens would or might,
yeah.
and we get that deeper color. So
Yeah. So I did take a slightly off course
that's
there,
okay.
but going back then to our total lunar eclipse phases, how long does each one of those phases? Look at this wonderful image coming in from Indonesia. I love that. That is getting such a beautiful, rich color. How long does each one of those phases last, Keith?
It depends. The penumbral phase is usually the longest because that's much larger, and then we get into the umbral shadow, not as long, but that's also variable depending on how well placed the moon is in that lineup between the Earth and the Sun. So the better it is lined up with that center point, the longer it can be. But there are other factors too that we don't hear a lot about. The length of totality can depend on things like where the moon is in relation to the Earth. So when the moon
Yeah,
is closer to the Earth, it orbits a little bit faster. When it's further away from the Earth, it orbits a little bit slower. So as it's orbiting slower, it will take longer for it to go through the shadow than it might. So that will contribute to a longer totality period. And we also have to consider the movement of the Earth. So the orbit of the Earth is also elliptical around the sun. So when the Earth is further away from the sun, it also is moving a little bit slower. So the longest that we can have for totality is actually 107 minutes. We had a record of, I think, 106:23, which was in 1859. 2000, I think we had no, sorry, 2018, we had 103 minutes, so just
Wow.
about at
Okay.
the total that you can get. But again, it's not just how well placed it is, it's also how far away the moon is from the Earth and how far away the Earth is moving, or how far the Earth is away from the sun, because
Yeah.
that affects how fast they move. So we're getting 82 minutes tonight. That's pretty good, but they
Okay.
can be longer. So it depends. It depends on a lot of where everything is placed.
Excellent. Actually, you were talking about that elliptical orbit. That's why the moon changes in apparent size. So sometimes when we look at it in some of Slooh's larger telescopes, like the Australia 1 telescope, I don't know if the studio can bring that up, but sometimes it barely fits within the field of view. But other times it appears quite small. So Australia 1 right at the top. So let's have a look at the live feed. This is a half-meter telescope. Switch off the round portal if you could. There you go. Oh, it's looking really dark now. The reason why the eclipse looks slightly different in Slooh's Australia half-meter telescope here is because it's a monochrome camera. This is actually a huge telescope with an ultra-sensitive CCD camera on the back of it, which is designed to capture the faintest objects in space. It's not that well suited for lunar eclipse and it doesn't show any color, but these are still going to show some terrific images, especially if you use the animation for this. So Keith, here we can see, the live image from the Australia 1 half-meter telescope, and we can see those graduations on the edge, which are about the size of the or the field of view. And what we're looking at here is actually this fits quite well. But I think in November we've got what's called a supermoon, haven't we?
Yep, definitely. This looks like the moon is closer to us, and the supermoon is what's happening there. The closer the moon is to us, the bigger it's going to look,
Yeah.
and the further away it is, the smaller it will look. With that, we see this with with solar eclipses, where the angular size of the moon has to be large enough to cover the disk of the sun. That's great. If it isn't, if the moon is further away from us, it doesn't completely cover the sun when we have an
Mm.
eclipse, and then we have an annular eclipse.
Annual
So yeah,
eclipse.
we are moving
Yeah.
into that cycle of the moon being closer to us. So that's probably one of the reasons why we have 82 minutes and not over 100 minutes, because it's moving a little bit faster, and as orbit around the Earth, it will move through the shadow a little bit more quickly. But pretty big, and you're right, it looks really good here. We're just minutes away from totality as it slips
Yeah.
into that orbital shadow.
Yeah, actually, this is an easier feed actually to see how close we are to the total phase. Now, I did preempt it a little bit, Keith, but let's go back to that topic of why the moon turns red, because I think you had a couple of diagrams here. So, why does it turn red during a total lunar eclipse?
Okay, so the sun, as I said, emits this very strong white light, which contains all the colors of the spectrum. And when it passes through something like the Earth's atmosphere, it acts like a lens and will scatter the shorter wavelengths of light that are the blue, the cold ends of the spectrum, blue, indigo, violet. That goes out into space. It's what gives the atmosphere that bluish color, a very beautiful color. And the longer wavelengths of light will sort of get funneled into the light cone. That's your red, orange, yellow parts of the spectrum. And as the moon passes through, that colored shadow is going to reflect off the very bright uh, light, very, very bright particles on the moon, what we call the highlands, those very reflective surfaces. And that's what gives it that reflective red color. And as you mentioned, atmosphere can also have a part to play depending on where we see the moon, whether it's very close to the horizon, and also the overall atmospheric health that we have here on Earth, whether there has been wildfires or whether there's been a lot of volcanic activity and things along those lines. So that can also have an effect in terms of how deep and dark and how bright the color is.
There's another color that we can sometimes see, and we might be lucky enough to see that. And it's usually during this kind of phase of a total lunar eclipse. And it's a blue band. I don't know if we can go back to the live feed because we maybe it's a little bit later maybe where this might happen. But we can sometimes land up seeing a kind of blue band between the red and the highly illuminated part. And isn't that the way? I think I've read that this is the way that light from the sun is being refracted by certain chemicals and layers in Earth's atmosphere. Is it ozone which that is associated to?
I'm not sure exactly what causes the change in color, but I've heard it described as bluish, sometimes turquoise. It's not just, when we talk about that refraction of the longer wavelengths of light, the red, orange, that's not the only thing going on. There's still a lot of other
Mm,
colors being emitted. So I think we're probably picking up a lot of that. It's never just all of one and not a lot of the other. There's still other stuff going on there. So it's a neat
yeah.
phenomenon. And
Uh,
I haven't
yeah.
seen it here, but that's not to say we won't see it. I've always thought of it something as the moon moves out of totality and we see it on the other side as it
Okay.
begins to enter into more of that light where that isn't affected by the funneling of the light cone. We're moving to the normal light, which is some of that blue light. But we'll
But
see.
we can see even now that, the spectrum of red light, which is being refracted, it's a lot deeper on the right hand side than it is on the left as the moon enters the deep heart of that umbral shadow, as you're talking about. Now, Keith, I have heard this particular lunar eclipse called the corn moon lunar eclipse. Where does that term come from? What on earth has corn got to do with the moon?
Well, it has to do with the time that the moon appears to us, or at least the full moon. This comes to us from Native American tribes and indigenous tribes, peoples who had a much closer relationship with the land than we have. It's really not that long ago that everybody knew this. You knew what was in harvest, and you knew that by going to the market. Most people now just go to a grocery store and they have no real relationship with what's happening out in nature, the seasons, the land, that kind of thing. Earlier peoples did, and that corn moon is a reflection of that. It's an expression of what was happening, in nature around the time of this particular full moon, and that, of course, is the harvest. We're
Mm.
harvesting corn, tomatoes, all those beautiful fall vegetables that we have in North America. And that's what would be harvested around this time, around September. We do have the harvest moon, but typically that's the moon that's closest to the autumnal equinox, the September equinox, which is coming
Yeah.
up. So this is not the moon closest to that. So that's kind of why we call this one the corn moon and not the harvest moon. That's a little bit later. But we have here in the slide, and this is from the lunar quest for today. That has some of the other names that we've typically called the moons. Those
Mm.
are, what's used here in North America, partially in Europe. It comes from the Old Farmer's Almanac. That's where we get a lot of these names from. But I know we have a lot of people from other parts in the world where we may be harvesting corn right now, but they're in
Mm.
springtime. They haven't even really planted yet. So, these names are subjective based on what we have on where we live. Other people would give these moons different names than what we do here.
So is this particular September full moon, is that called different things in different parts of the world?
Yeah, it does. Different cultures will call it different things. I know in England this is referred to as the barley moon
Yeah.
because of the harvest of barley. The one I really like, I think in one of the tribal traditions, it's referred to as the animal growing fur moon. And
Oh, I
if
love that.
anybody has been around livestock, I was an avid horseman for many years. Animals will begin to grow their winter coats not because it's cold, but because of the length of night and day. They know that they're provided for by nature, that when the evenings get longer, that they need to start growing their coat. And that's exactly what happens. And one of the native peoples refers to this as that when the animals grow fur moon. And I think that's my favorite.
Yeah, I love that. I love that. So kind of celestial calendars, aren't they? We're seeing some bright spots on here, Keith. I believe those are bright stars, and it looks like the moon is about to occult, or that star has just come out from behind the moon. But look at the deep, rich color of this beautiful, beautiful blood red moon eclipse from Indonesia. It's pretty cool, isn't it?
Yeah, we've got that 1 o'clock position that's close to the center line and it's dark. It's fully in the umbra, the left-hand side. The western limb hasn't moved into it yet. You're right, the stars are going to get covered up by the moon. As the moon moves and makes its way into the shadow, we will lose the stars and they'll pop out the other side. Very excited when that happens. Really cool when it happens with planets. We've seen lunar
Yeah,
eclipses in the past where we all have the lunar eclipse and an occultation of a planet,
yeah,
which is really, really a double treat. We're not having that
yeah.
today. We're just having stars.
Yeah, one of the, in fact, the moon this evening and tomorrow is very, very close to the planet Saturn. So
Ah,
if you are looking at the moon tonight or tomorrow night and you see what appears to be a very bright star close by, then that's the planet Saturn, which is approaching opposition later on this month. Keith, I don't know about you, but I am really looking forward to seeing the posters that students create out of all of the images that are snapping from the live feeds tonight. And we're going to talk a little bit later, aren't we, about the Lunar Eclipse Moments Quest.
there is a special Moments Quest just in honor of this event. So, as you mentioned,
Excellent.
students at home, Slooh members want to take the quest, which I recommend everybody do, you want to be snapping pictures. You want to get as many pictures of this event as you can, because I think we have 39 or 42 slots available for that. And
Yeah.
not just that, you can use one of these full moon images in your Lunar Phases quest if you want. You might be able to put in uh, an eclipsed moon, a blood moon, into your lunar phases quest. So you have a couple of opportunities here.
Excellent. Well, we'll talk about that a little bit later. For now, Keith, thank you very much for sharing your expertise and enthusiasm for blood moon lunar eclipses. We'll see you later.
Very good, thank you.
So we've seen how September's full moon has carried many different names across cultures. But the moon isn't just about names. It's also been the spark for myths and storytelling and traditions around the world. And just imagine, for thousands of years, people have looked up at the same darkened moon, just like we're looking at now, with that same sense of awe and wonder, weaving myths and stories to explain what they're seeing. And tonight, we get to share some of those timeless experiences. So, anyway, next we are going to head over to Western Australia and the Gravity Discovery Centre and Observatory, where Rick Tonello has been struggling with the weather down there. The centre is a remarkable place dedicated not only to exploring the science of space and gravity and the universe, but also to inspiring the wonder under the spectacular skies of the Southern Hemisphere. Now, Rick plays a key role in sharing that experience with the public, and tonight he'll be, hopefully, if he hasn't been totally rained off, he's going to tell us a little bit about how lunar eclipses have been seen for millennia in Australia. Rick, can you hear me?
I can, loud and clear, Paul. How are you?
I'm very well. You're looking a little bit damp, Rick. I know that you were jumping in your car earlier to try and find what some of us in astronomy call a sucker hole, which is a tiny, tiny little hole in the cloud. You set up all of your equipment, and by the time you're set up, it's clouded over again. How has this eclipse been for you so far? It doesn't sound like it's been the most relaxing experience.
And it's been a bit frustrating, to be honest. I just earlier this evening, I did a 300-kilometer round trip to
Oh,
another observatory that I co-manage, and it's unfortunate that the weather system that has just passed through us for the last weekend, the last couple of days, has been just carrying through, and we're just getting patches of cloud. But at the moment, I am under a solid blanket of cloud. I did beam out some images just a few minutes earlier, and it looked okay. I started to see the color and in the umbral shadow, and it was looking very promising. But then before things started getting really interesting, the cloud just came over, and it is currently drizzling at the moment. So my telescope is all covered up, and yeah, there's not much I can do about it, unfortunately.
safeguard the equipment, and you and I have been doing this for long enough to know that there's one thing that we can't control, and that's the weather. So let's take us back though, because I still want to talk to you about your work at the Gravity Discovery Centre and the observatory. What 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 do visitors experience there? How does it connect people to the universe? Because you and I have had a couple of calls with Gretchen, and we share such a common mission. We are passionate
Yes.
about getting astronomy into the hands of as many people and students as possible. So what do you do at the Gravity Discovery Center?
First of all, we're actually a hands-on interactive science center. So there's two parts of the place. There's the actual Gravity Discovery Center, and then there's the observatory, which is affiliated with the Gravity Discovery Center itself. Now, initially, the Gravity Discovery Center was set up because just in the same precinct, there is a gravitational wave interferometer. So the gravitational wave interferometer detects shifts or waves in the fabric of space-time, as predicted by Albert Einstein way back in 1915. He said that these ripples in space-time exist, but we'll never ever find them. Now, the gravitational wave detector that is at the GDC is not big enough to detect any ripples, unless, of course, I heard it described once the entire Virgo supercluster of galaxies collapses down upon itself, and we'd certainly know about that if it did. But this is certainly an outreach center where people get to see the differences between Newtonian gravity and Einsteinian gravity, and it certainly doesn't illustrate that Newton was wrong, because he certainly wasn't at all. It's just Einstein's view on how gravity works is a little bit more elegant. So the center is there to connect people with physics and just basic concepts of movements and inertia, etc., but also to describe how space is curved by the mass of an object, and starting to bring Einstein's ideas on how gravity works to the fore, and with a lot of hands-on interactive examples. We've got a space-time simulator. It's a trampoline with some spandex on it. You put a heavy ball in the middle of it, and you can do orbits, you can do slingshots, you can do spaghettification. It's wonderful, and people love it, and it's a really powerful tool to get people to understand that. But
So
more than that,
very hands on, but you've also
it
got
is.
the observatory as well. And I know you do a lot of outreach work there.
Yes. Yeah, that's my domain actually. And we're now starting to go more into the astronomy, astrophysics, and bringing the gravity side back a little bit, because gravity was quite, hence the name, Gravity Discovery Center, was quite at the fore. But we now want to bring the astronomy and the astrophysics more to the fore, and that's where we do it at the observatory. And the observatory is a large building with a roll-off roof, a number of telescopes in there. And of course, the thing that we pride ourselves the most with is our beautiful dark skies. We're located just a
Yeah.
little over an hour's drive north of Perth, the capital city of Western Australia. And we've got some beautiful dark skies, which we're working very, very hard to keep as a dark sky area for research, for education, for tourism, for protection of the local wildlife, etc. But we're actually going towards becoming an international dark sky reserve,
Brilliant.
as accredited by the Dark Sky Association. So we've been
So,
working on that yeah, sorry.
so will that include some local laws to reduce or eliminate light pollution from the lights from houses, security lights, always worth saying, street lighting and stuff like that? Is it going to be accompanied by that kind of protection?
Yes, absolutely.
Brilliant.
We've in the early days of it, we've actually worked with the state government, the Department of Planning, Lands and Heritage, who drafted up a position statement, as they call it, which outlines, you must keep these areas around astronomical observatories. You have certain types of lighting, as dictated by the Dark Sky Association ideals, I should say, principles. So we've got that in place, but also the local shire, who manages the shire, which is a little over 2,500 square kilometers. Oh, sorry, 3,224 square kilometers. I remember that now.
Wow.
They manage that entire area, so they do apply the local building laws, and they actually have. And I'm proud to say that they have been one of the first councils in Western Australia to implement lighting laws, to actually say you cannot light up or cannot have this kind of light. You must adhere to dark sky principles, which is
Yeah.
fantastic.
Yeah.
So we're really working hard. We're just going to do a couple of examples, and then we'll submit our final application. So we're on provisional status with the IDA, which is really encouraging, and I'm very, very
Well,
happy to say.
it sounds like you're on an absolute mission there. And frankly, you probably find it with the students who visit the Gravity Discovery Center, but we find it with Slooh students who start using our telescopes. And they even see our all-sky camera from our Canary Islands Observatory, which the whole of the Canary Islands has special light pollution laws to protect their skies. They value it very carefully. But a lot of the students who come in, they rarely see anything but a bright star or a moon or a planet in the sky. They certainly can't even make out a lot of constellations because of the light pollution, especially from cities and urban areas. But you've also got incredibly rich skies, haven't you, in the southern hemisphere? I mean, there's a lot of really cool celestial objects down there.
Yeah, we do. We are very, very spoilt down here. I mean, for example, in the middle of winter, right at zenith is the center of the Milky Ways, the galactic bulge.
Yeah,
And of course, we've got the Magellanic Clouds, the large and small respectively, plus the Southern Cross and the pointers. And I could go on. The amount of targets that we have, it is a target-rich environment. It's like shooting fish in a
yeah,
barrel.
yeah,
You could point your telescope anywhere and get the amazing things. And it's great because we do get school students to come up at nighttime to the observatory to experience these dark skies, to look through our telescopes, to learn more about the universe in which they live. But sometimes students can't make it, so we bring the universe to them. We do actually incursions at night where we take telescopes out to the particular schools to give these kids the experience of actually looking through a telescope. And of course, the two major favorites is the moon and Saturn. And now that
yeah.
Saturn's coming back into season, it's yeah, bookings are starting to get quite busy, which is very
Yeah,
encouraging.
yeah, we've had a few Slooh students who have posted observations, which are images that they've captured with the Slooh telescopes, and some of them have posted images of Saturn, and they said, "Where are the rings?" And of course, Saturn is very close to its equinox at the moment, so the rings are
Yes,
kind of edge on virtually, so that can make
yeah,
them quite difficult to see. But that's one of the lovely things about astronomy as well, that you can track it over years. And one member produced a whole seasonal diagram of Saturn when its rings were pointed most to us and now edge on and then coming back again as well. But let's get back to the lunar eclipse for a moment.
yes.
First of all, what do you reckon? I'm slightly jealous that the moon isn't risen here yet in the UK, so I don't even get to see this. You've got horrible clouds overhead, so you can't see it. This is the feed from Indonesia. What do you make of it?
I think it's lovely.
It's pretty cool.
It's just, I mean, just seeing the moon turn that coppery orangey color
Mm,
certainly stirs up feelings for myself as an astronomer of the remarkable mechanics of the solar system, as
yeah.
explained by your previous guest, the 5 degree tilt of the lunar orbit around Earth, and how it doesn't happen every month, um, and just how those that interplay with that timing just happens,
Yeah,
and also the physics of light and how the light gets scattered and how it gets broken up into its individual wavelengths, and some gets absorbed by the atmosphere and some gets scattered deep to give us that beautiful coppery orangey color. I
yeah,
think it's absolutely wonderful. I feel as though um, sometimes it can be spoilt with a little bit of superstition, where people herald this as a mark of bad news or something bad's going to happen. Even just the full moon, the apparition of the full moon.
yeah,
I know
yeah,
people in the law enforcement industry, but also in the
yeah,
emergency services, and they go, "Oh, people are going to go crazy tonight because there's a full moon." It's like there's no
yeah.
scientific evidence for that,
No,
apart from
there
the
isn't.
fact that it provides enough light for people to do stupid things.
Exactly, exactly.
Yeah,
So there is a whole stack of fascinating science about this, which we've
yes.
already explained. But in Australia, it's home to some of the world's oldest continuing cultures with a deep storytelling tradition. Could you share some of the perspectives, the stories, traditions, or myths connected to the moon and eclipses? Because whenever I see an event like this, I'm sitting there and I'm 7 miles away from Stonehenge, and I'm thinking, what did the people back then think was going on? I mean, you can see
Mm.
why this could have been frightening or In other ways, something that needed explanation. Why have we seen the moon turn red? It's normally white. So, what have you got down in Australia as far as that sky law is concerned?
Indeed. So where I reside is in the Noongar Nation. Now, there's over 250 different language groups in Australia, and each language group is pretty much its own nation, really. So the stories that you'll hear from, say, Perth in Perth, Western Australia, or in the south part of Western, the southwest parts of Western Australia, that's Noongar country. You travel up to north to Geraldton, which is about nearly 500 kilometers away or thereabouts. You get into Yamaji country. You go out east towards Kalgoorlie, which is a 6-hour drive east. You get into Wongai country, and each area's got their own stories based upon their own environments, etc. Now, and there's also different initiation rites as well. So what I've been told, I did manage to, before this broadcast, did manage to have a bit of a sit down with our dear friend and learned colleague, Dr. Noel Nannup, who's a Whadjuk Noongar elder. So the Whadjuk group is from around the Perth region, but where I work up at the Gravity Discovery Centre in Gingin, which is about 60, 70 kilometres north of Perth, that is Ued Noongar country. So you get little different groups within the actual nation. Anyway, so I was talking to Noel about the law behind the moon, and uh, the Noongar people see the moon as a father figure. They call it Mika. Now, Mika is the father figure, and of course, it ebbs and flows, it comes and goes. So just like um, Dad, the father of the group, the fathers would go out and they would hunt, and of course, the moon, they would disappear. But then he'd come back and everyone's spirits would be lifted because Dad would bring home food. And Dad's home, this is great. Dad's bought food, Dad's back home, we can play with him. And everyone's spirits are lifted and everyone's having a great time. But then the moon leaves again. It's time for Dad to go back hunting again. So the energy levels tend to drop down. But the mythology behind the eclipse moon, that does herald kind of bad news. This is for the
Okay.
Noongar people, and this is very limited to what I've been told because, again, I haven't been initiated into their society. So you have to go through different stages of initiation to learn deeper and deeper levels of meaning of things. So as uh, as a white fella, as they call it, um, as a white fella, I can only be told so much, and I fully respect that. So,
Yeah.
from what Noel told me, he said basically this is when, um, if there was a punishment that had to be dealt out, it would be done about now. So this was heralding, not a very pleasant thing to be done.
Okay.
So that's about all I've been told. So, but other groups, other nations, they see it as someone has died or on their travels, or someone has gotten sick or something like that. So it is a harbinger of doom or gloom and doom, the moon. But I suppose it is a psychological thing where you see it red. It's like when Mars, of course, they named after the god of war. It's red, it's blood.
Yeah.
It's bad. So I can see the link between the coppery orangey color and the linking that of heralding some
Yeah.
bad news or the upcoming things of bad events coming forth. So, but yeah, that's about all I've got with as
Rick,
far as the Noongar perspective. Mm,
I think that's fascinating. That's the first time I've ever heard of any cultural storytelling which is revealed over a period of time to build an understanding, a greater understanding. And so some of the things that you were saying there are draw a very close parallel to some stories from South America, halfway around the world, that we're going to hear a
mm,
little bit about later. And this is what we tend to find, isn't it, when it comes to sky law? The same kind of explanations are given by these cultures that are separated, who've never met by thousands of miles over sometimes millennia, but the
mm,
explanations are so often very, very similar. But we can see here, if you see, an ancient civilization or culture looking at the moon turn a dark red blood color, you can
mm,
see naturally the associations that they might start drawing from that. But there's also other examples as well, of course. Comets were seen by many civilizations as being the harbinger of doom, but wasn't it Attila the Hun? I think he saw it as a good omen that he should go to war because he knew he was going to win a war. So there's always another side to the story. So,
Yeah.
you, but,
I I
Rick,
think Attila
what?
the Hun was always itching for a fight, but anyway, there you are.
Yeah, there is that.
Yeah.
There is that, I guess. Yeah, yeah. Any excuse. Rick,
Yes,
it's
yes.
wonderful to have you here. Tell us where people go to when you're open down at the Gravity Discovery Center.
Oh, well, so we're open both during the day, so people can come and visit us if they're driving past. So we're located north of Perth, about an hour's drive up Indian Ocean Road, and you can find us online to get a direct point of where to go to. But so we're open pretty much every day, with the exception of Mondays. But the observatory is open generally on Friday, Saturday, Sunday nights. But during school holidays, we're pretty much open every single night because we just get people booking in, and we put on a lot of nights during school holidays. The last school holidays, I must say, were quite wet, and we did have a lot of rain, so we didn't operate at full capacity. So our numbers were down. But now that we're coming into our other school holidays toward the end of September, early October, and with the promise of some more congenial weather, we are hoping to get our numbers back. But you
Excellent.
can check out our website and come along and make a booking and come along and experience some beautiful dark skies and talk to some charming and witty astronomers and yeah,
Such
have a
as your
great
good
night. And
self, yes.
I didn't want to say that. I'm probably the most miserable of the lot of them. But yes, my team that I work with, my colleagues, are absolutely fantastic people, and a lot of them are going for their either bachelor's or master's. I had one who's just completed his PhD in high energy astrophysics. So it's yeah, and we're very, very passionate. We love what we do. We love sharing what
Yeah.
we call the PB&J, the passion, beauty, and joy of astronomy.
Yeah. And honestly, our discussions with you over the last couple of weeks have been inspiring in their own right. Hopefully Slooh and the Gravity Discovery Center, with such common goals and ambitions, we're going to find lots more ways to collaborate. What time is it there, by the way?
It's currently 2 minutes to 2 in the morning.
Okay.
So it is the 8th. Yeah, so it's the 8th of September, 2 minutes to 2, so 1:58 local time.
So have you got a long drive to do to get home?
I'm home at the moment.
You are. You
So I'm
got
coming
home.
to you. I'm
Thank
coming to you.
goodness for that.
Yeah, look, driving at night time is fraught here in Australia because we do have the what we call the spring-loaded marsupials, the kangaroos,
Yes, yes,
and
I
they're not the
have been
sharpest tools
there.
in the
Yeah.
box. Mm. But I
Yes.
made it home in
And
one
yeah.
piece.
Yeah, I've seen several cars written off when I was down in Australia, having come into contact with one of your kangaroos, and the kangaroo
Mm.
normally hops off unscathed, but the car is normally written off. Rick, I hope to see you, and I hope to visit the Gravity Discovery next time I'm down in Australia. But for the meantime, thank you so much for doing so much work over the last couple of weeks, because we had some wonderful test feeds from you that you set up. I know you've probably traveled quite a few hundred kilometers trying to find some clear skies for us tonight. But for now, thank you very much for all of those efforts, and enjoy the live views. And we'll
Yes.
hopefully see you very soon.
Thank you, Paul. Thank you for having me on.
Thanks, Rick. Take care.
You too.
Wow,
Thanks.
what a wonderful guest, and honestly, you wouldn't believe how much work Rick has done over the last couple of weeks to get prepared for this. But as we all know in astronomy, we can't control the weather. But let's welcome back, as we watch this glorious, glorious blood moon lunar eclipse here on Slooh. Let's welcome back Keith Wozelewski, Slooh educator. Keith, hi, are you there?
Yes, I am looking good, Paul.
What do you make of the live image feed from Indonesia at the moment? This is a good one, isn't it?
Yeah, this is about as good as we've seen for a total lunar eclipse. Beautiful, beautiful color. Again, that dark, deep rich orange color, not really red, although the media loves blood red moon. A lot of times we see where it's like a lighter color, a peachy color. This is definitely very dark. We are in the middle of that umbral shadow right now. I don't know when maximum totality is, but
We're about 12 minutes away from
yeah,
maximum totality. So this is, and we can, as you pointed out there, we can still see some graduation of the
yeah,
color over the surface of the moon with the white or paler part of that on the left. Um,
that's
but let's talk about, because it's a rather good time to talk about lunar features. Now, you would think, and I thought this for many years until I started observing, that a full moon would be the best time to see loads of wonderful lunar features. But is it?
the moon is so bright and reflective that when we look at a full moon, a lot of that detail that we would expect gets washed out, especially with the
Mm,
naked eye. You go out and you look at the full moon, there's not a whole lot to see. When we use something like a telescope, especially the Slooh telescopes, the exposure, I'm going to guess, is tuned down quite a bit. So at the full moon, we
mm,
do get to see a lot that we wouldn't normally see. If you point a telescope at the full moon without a filter, you're going to be blinded. There's not much going on there. Here, because it's the eclipse, we can definitely see two main things going on. Uh, this lighter portion and the darker portion. The lighter portion that we see reflecting the light from the light cone, this red, orange, yellow from the spectrum, that is part of the moon's crust. This is very, very old material that is the moon cooled. This is the part that formed the crust. On the far side of the moon, that's pretty much all we see. We don't really
yeah.
see these darker areas that we call maria or seas. Different theories about where these came from, but I think it's really a combination of the two. Large plains of basaltic lava, which are very dark. They absorb light. They do not reflect light. Very different than the so-called highlands that reflects all this light. The darker patches don't reflect light because of the material. It's a different type of rock absorbing all this light. Again, a remnant from these large pools and plains of lava that cooled as the moon was cooling. But also the results of impacts of craters. We see a lot of these mare are actually the results of asteroid impacts breaking through the crust of the moon and releasing lava, basaltic lava that way, which then in turn would cool. So we definitely see the obvious difference of the very dark patches and the lighter regions of the lunar crust.
So why are the Maria so dark then in comparison to the rest?
It's because of this material. Basalt, mostly basalt is the main body of the material. It's very iron rich. It doesn't reflect light. And in order to see this brightness, we need to have reflectivity. And the moon, actually, because the mare, the seas, are so large, its albedo, its shininess, its brightness, it's the way that it reflects light, is actually lower than we would think it is. It just appears to be very bright because it's so close to us. It's because of the composition of the rock, because of
Right.
the lava. If you're on the moon, it doesn't look dark like this. It doesn't look smooth at all. In fact, the Apollo 11 mission landed in one of these mare, in one of these seas, and it just kind of looks like rock and dust and other stuff. Doesn't look
Yeah.
dark at all.
It's more the contrast, isn't it, from our particular perspective. So you've called these Maria, means sea in Latin, but they're basalt, so they're anything but seas.
Yeah, no, these are lava flows that either are remnants of the cool down period when the surface of the moon was covered in large masses of this, but also they are the result of these asteroid impacts breaking through the crust of the moon and releasing this basaltic material, this lava, basically bubbling up to the surface and then cooling. So yes, they are not seas. But, this goes back to really Galileo, who wrote the book, literally, on looking at the moon.
Yeah.
He's the first person who recorded looking at the moon through a telescope. And in 1610, I would imagine that they did look like seas because they are so much
Yeah.
darker than the surrounding areas around them. And even when you go outside and look at the full moon, they do look kind of like seas or oceans. And we can even see that here. It looks like that to me.
Exactly. But as soon as, of course, telescope technology improved, they could actually start seeing craters and other features. in those large dark areas, which would have dispelled that. But so we can't really see. We did see earlier on, didn't we? We saw some um, rayed craters, which almost look bright. They're huge rays, some of them almost spreading across the entire surface of the moon. Why did those look so bright in comparison to the other areas of the moon?
Yeah, I have to admit, I love the full moon because we get to see certain things like the mare,
Yeah.
the contrast of light and dark, and these large craters, these rayed craters. The most famous rayed crater, of course, is Tycho. We have to imagine an asteroid coming in, slamming into the surface of the moon. And there is no atmosphere, so they're not going to burn up. They're going to hit the moon with the full force that they carry with it. When they hit, they're going to cause a large dent, a large basin in the moon, and it's also going to send out all the material, all the dust, all that lighter material that's on the top. That lighter material is less dense than is the basaltic rock beneath it. So if you can imagine taking a stone and dropping it into dusty a dusty patch on at your house, all that ejected material, that's what we call it, is going to go out and spray out in different directions. When we see the ejected material, we know that the crater is younger than the craters that don't have it. The craters that don't have the ejected material would have had it, but there is a type of erosion on the moon. The moon doesn't have erosion because it doesn't have water, it doesn't have an atmosphere, it doesn't have air. That's what leads to erosion on Earth. But it does get bombarded by micrometeorites, by debris, by stuff from outer space. It's also subject to solar wind and the intense amount of radiation coming from the sun,
Yeah.
which tends to bleach a lot of these rays over a very, very long period of time. So as a crater ages, it will eventually lose this ray effect that we see and look forward to, signs of the impact. But impacts that are newer and more recent than those will still have the rays, and that's why we see them in craters like Tycho, Copernicus, Kepler, some of the famous ray craters that we see at the full moon.
Yeah. Well, before I let you go for this segment, Keith, what is your favorite phase to be capturing the moon with Slooh's telescopes?
A lot of people like when we have the terminator, which is the
Yep.
separation of the part of the moon that we can see and the part of the moon that isn't illumined yet. I happen to like the full moon because we get to see, again, the mare. We get to see the rayed craters. You don't always see the rayed craters. We also
Mm,
see certain clair obscure features, like things like Cassini's Moon Maiden. There's a lot to see with the full moon. These beautiful impact craters like Aristarchus. I like the full moon. I like also when we're right at first quarter because we get to
yeah.
see the lunar X and V and the golden handle, and we've had a lot of live streams of that. Really, really neat to see these objects that are not visible, interplay of light and shadow that reveal themselves and then vanish almost as quickly as we see them. So,
Yeah, I think I'm with you there all the way. I do like around a quarter moon. I do like those when we see all of that lovely crisp detail, and when we see some of the high magnification views, you see the shadows being cast in a crater, and then slowly revealed over a period of hours as sunrise is occurring over the craters. Well, Keith, you're going to be coming back a little bit later. We're going to be talking about our Moments Quest. I really cannot wait to see some of the posters that students are going to create from that. But we'll talk to you later about that. But for now, Keith, we are going to hop over to Indonesia. So thanks, Keith. So let's head across the globe to Indonesia, where Yatni Yulianti is standing by the historic Boscha Observatory, which is where this epic feed is coming from at the moment. Yatni, can you hear me?
Oh, yes, Paul. Hello.
Hi, how are you?
Oh, I'm fine, thank you.
Thank you so much for sharing what I think is one of the best blood moon total lunar eclipse feeds we've ever seen. So tell us a little bit about,
Mhm.
I don't even know if I'm pronouncing it correctly. Is it the Boscha Observatory?
It's Bosca.
Bosca. Okay, so
Bosca, yeah.
where are you and what do you do? Because I believe you do quite a lot of outreach, public outreach there as well, don't you?
Yeah. So, Bosca Observatory is the oldest astronomical modern observatory in Indonesia. We located in Lembang city. It's about 15 kilometers from Bandung city. It's one of the biggest city in Indonesia, in West Java. So I work at Bosca Observatory as an outreach manager, and I have a lot of work on developing educational material and having a teacher training program and such with my colleague here. So that's what I do here at the observatory.
So we see so many differences in the way astronomy is taught around the world. In a lot of countries, astronomy doesn't feature on the curriculum at all. What's it like in
Yeah.
Indonesia?
Yes, it's the same thing also here. So the student learn about astronomy is on fifth grade or sixth grade elementary school. Uh, they they learn bits about moon, Earth, and the sun system. And on higher level education, they learn astronomy inside the physics study or maybe geography study.
Okay. So does Indonesia, I mean, we've seen this burgeoning space industry around the world.
Mm.
Does Indonesia have any burgeoning space industries going that students can get involved with?
I think we don't have a big space industry, but we are getting to satellite industry now. So
Yeah.
yeah, young people can see it as a promising career in the future,
And
hopefully.
astronomy is such a wonderful science topic to introduce so many different
Yeah.
aspects. We've been
Mm,
talking tonight about it's not just about the science and technology that's behind
mm,
astronomy, but also the cultural and symbolic significance of events like this.
yeah.
So,
Mhm, mhm.
what can you share with us about some of the traditions connected to eclipses in Indonesia?
Yeah, in Indonesia, the eclipse are not only an astronomical event, but also carry a cultural meaning. One of the well-known story is come from Japanese. It's one of the our big island here in Indonesia, and it's a story about Batara Kala. Batara Kala is a giant who try to eat the sun or the moon during the eclipse. So people believe that Batara Kala was devouring the light from the sun or the moon. And to scare him away, people or the community would make loud noises, banging drums, gongs, or even kitchen utensil until the sun or the moon release from the Batara Kala.
I'm
So it's
smiling. I'm smiling so much because
Mhm.
you are halfway around the world
Yeah,
to South America, and we are
yeah,
about to hear a
yes,
story which is
story.
remarkably similar with a
Yeah,
jaguar.
yeah.
I'm not going to spoil the story totally, but it's about a jaguar
Jaguar,
eating
yeah,
the
I've
moon.
heard it.
And
Yeah,
yeah, so uh, isn't it fascinating how I was talking to Rick just now about this, how different cultures around the world who never met, who
yeah.
never had written records, but came to the same kind of storytelling,
Stories.
myth and lore about these celestial events. Isn't it
Yeah,
wonderful?
that's the wonderful thing about astronomy. But I think what we always say to the student or the community here that we only have one sky here.
Yeah,
So we only see the same moon. So I
yeah.
think that's what connect us having this phenomena. It's very
It
incredible to
is.
bringing people together.
It is. Have you got many students and visitors at the observatory tonight to witness the eclipse?
Oh, we don't have a visitor tonight, but we having a live stream on YouTube also, and I think we got quite a number of audience there. And
Excellent.
also we have a campaign through social media, through Instagram, so people can share their photograph, their video with us, and so we are going to post it tomorrow and sharing the story.
Well, we will certainly keep an eye open for that because, frankly, your image feed tonight has saved us a little bit because Australia was clouded out, and this has
Wow,
been absolutely a stunning,
wonderful.
stunning image feed. So, thank you very much for that, Yatni. Now,
Thank you
we
for,
must discuss more about some future collaborations because it
yes,
would be
surely.
yeah, wonderful for some of your students and visitors to be able to use some of Slooh's telescopes around the world
Yes.
as well,
Mhm,
because it gives
mhm.
them daytime astronomy from Indonesia. So that would be quite cool. So, Yatni, thank you so much for joining us
Oh, thank you for
this
having
evening.
me.
What time is it there, by the way?
It's 16 past 1, so it's just
Okay.
only 5 minutes away from the totality.
So are
Oh,
you going to
yes.
stay up and watch the entirety, or will you be heading off home at some point?
I'm home now, but my home is at the observatory as well. So
Right.
after this, I'm going to join with my friends and colleagues having the observe the moon.
Brilliant. Enjoy the rest of the event there, and thank you so much for the live feed tonight. Our students are
Thank you.
snapping images of it, and they're going to be creating some wonderful posters that we'll share with you as well. So thank you very much for joining us.
Thank you.
Take care. Wow, this is a cracking event tonight, isn't it? And that's from the Bosca Observatory in Indonesia, who's been providing the wonderful feed that we've seen of the blood moon lunar eclipse. I know Keith doesn't like that term, but I do. Blood moon lunar eclipse, quite cool. Actually, it's related a little bit to our Falling for the Moon competition, as we enter kind of spooky territory coming up to October. But now we've got some more lunar mythology. Now, I hope it hasn't been too much of a spoiler, but we're going to welcome Milton Villarol, who does our Spanish space science classes. Milton, are you there?
Of course I am, and enjoying the show as most people in around the world.
Now, you've listened to some of that storytelling from Australia and then from Indonesia. The Indonesian one struck me in particular about how close it is. Some of the stories that you brought to us about a blood moon from the Aztecs, Maya, and Inca. So, start off with what was the Inca interpretation of a total lunar eclipse like this?
Well, as some cultures in Central America, we thought that jaguar, the only animal capable of jumping that high, let's say, would eat or harm the moon. And people around would make all sorts of noises trying to scare it away, protect the moon, because to them, the moon is a goddess, right? The goddess of womanhood, the goddess of life, etc. And so they really wanted to protect the goddess from the jaguar attack.
The Jaguar, yeah. Wow. I mean, it sounds so in Indonesia, it's a giant, which is devouring the moon, and they're banging drums and banging things to try and get rid of the giant. And it sounds like the Incas were doing exactly the same thing to the Jaguar.
Yeah, I think, as the more I study ancient cultures, I think there is only one way they could, explain what was happening in the upper
Mm.
world. And it could take the form of a big cat, or it can take the form of a monster or a giant in this case. but all of them coincide that the moon is being under attack, and we have to do something about it. It's an opportunity for everybody to think about this situation and realign the thoughts about the moon.
So in South America, were eclipses always considered to be bad omens, and were they able to forecast? I think they did quite a lot of calendar work down there. So were they able to forecast and prepare for these eclipses?
The Maya are very famous for calendar, studies, and so they were the ones who could eventually forecast some of the eclipses we have seen. The Inca knew more eclipses would happen, but they didn't know when exactly. So when those happened, they interpreted them as either bad omens or probably good news from the sky. Normally in South America, it was considered a bad omen for any kind of eclipse.
So did it influence their daily lives in any way?
Yeah, because for example, as I told you, when this attack came, it made everybody rethink about how vulnerable the god, this moon was, let's say in this case. And so more worshiping, more attention was given to all the sacred ceremonies they have. That happened in South America. The Aztec, for example, sometimes considered an eclipse an opportunity, for example, to go to war, and they would prepare for that. Sometimes bloodletting, in this case, for example, they prepared for war by giving back some of that blood and, try to ask the gods for a good result in that war.
As modern observers, can we learn anything from some of these ancient views?
I think so. Personally, I really think so, because I think, that being in contact with the cosmos, being in close touch with everything else,
Mm,
it gives us a sense of perspective. Life is more valuable when you think yourself as part of a bigger thing, a part of
yeah.
Mother Earth or the cosmos in general. So anything happening around us connects us with that energy. And so people all around the world will at least, feel the same kind of feelings we feel tonight observing this celestial,
Yeah.
celestial happening here.
It's exactly that. And look what we've had in the show. We've had people from Australia, Asia. We've had some people from India involved as well here. Now we're talking to you in the Americas, and we've got Keith in North America. I mean, it is. I know we've got students looking in from around the world as well, capturing these wonderful images. It is a real collective moment where we're all sharing this glorious, awe-inspiring celestial event together. So, Milton, you're going to stick around because we're going to have a little bit of a joint discussion after Keith has told us a little bit about one of the Moments quest. We'll maybe talk to you as well about your quest as well. So stick around, Milton.
Excellent.
We'll see you in a few moments. So let's go. Straight, actually, can we have a look? I don't know if the Australia telescope is still able to see the moon. It is looking, it's pretty dark there. So you can see this is a monochrome camera on a very large telescope at our Australian observatory. You've got some cloud down there as well, just like Rick had. But that's going to be an interesting series of images. And we can see we are already past maximum eclipse so that we can see the moon is brightening once again, and we can see it here in the Indonesian feed as well. But Keith, are you there? Are you with us again?
I am. Looks great. Very interesting what everybody has to say. Again, a wonderful image of this blood red moon. I'll call it that for you, Paul.
Oh, thank you very much.
I
I've beaten you down after so
I don't know.
long,
I don't
Keith.
have a problem with blood red. I'll tell you what excites me about this is that
What's that?
as a Northern Hemisphere person, I finally get to see in a live view the rabbit in the moon. I've
Yeah.
seen the head, but I never really saw the body. But here I can very clearly see the body. I see her cottontail. That's my added bonus from this event. Not just seeing the beautiful color of the moon, but also seeing the rabbit in the moon.
The rabbit in the moon. I love the way that we humans like to see and discern patterns in the things that we see. But Keith, before we get anybody else back in for a little bit of a joint discussion before we wind up, we are going to continue the live feed so students can and members can carry on capturing live feeds for at least another half an hour. There is a moment's quest. Now, we hinted at this right at the beginning, but can you tell us first of all what a quest is at Slooh?
Yes, quests are learning activities where we get to use the Slooh telescopes and we get to follow along with a printed informative text that tells us what we're looking at. And it's very hands-on. We get very involved. In this instance here, the corn moon total lunar eclipse, because this is a point in time. It's not happening tomorrow and it didn't happen yesterday. You have to be taking pictures from the event today in order to add those into the quest. It is time dated, time stamped. So
Yeah,
that's what a quest is. There are 9 pages of quests, and I looked the other day of learning activities and so much incredible information. Dr. John does such a fantastic job with the quests. Some of the older quests are still worth taking as well. They're just
yeah.
fantastic material, very informative.
Yeah, our quest development team made up of Dr. John Bover and Kelly Ritz. I mean, they're doing just such a spectacular job, and we keep extending both into some of the more fun quests that revolve around mythology, like some of the ones that Milton has written, through to some new advanced quests as well, where students are getting really deep into some research studies as well. So, what can students expect from this particular quest, Keith?
In this particular quest, the Corn Moon Lunar Eclipse quest, we learned what an eclipse is. It's basically a summary of a lot of what we talked about on the show today. So you're going to learn what the eclipse is, what the eclipse conditions are. There are slots for your poster, of course, which is the little reward at the end. Snapping your images, inserting those images into the quest that will be added into your poster. And of course, the poster is the show and tell object that you can download and save as I think as a PDF or some type of file that you can
Yeah.
share on Slooh. You can also share with your friends. You can send them to people in your family. Everybody can have a copy of it. You can actually print out the poster if you want to and have an actual keepsake of the
Yeah.
event that we looked at today.
And they can enter those posters into the Falling for the Moon contest. Now, Keith, you have mentioned something there. You know, there's lots of science and astronomy lesson plans out there, but biggest the biggest engagement tool I always think with Slooh Quest is every single quest requires the student or member to capture images using Slooh's telescopes at our Chile, Australia, and Canary Islands Observatory. And normally on a quest poster like this, anything that's bordered in white is normally an image that students have captured from the live telescopes. So I think we're looking forward to seeing what's coming out over the next week, aren't we? That's going to be filled in that box. I think you said there were over 40 images that students can arrange in this poster in any way they like.
Yeah, from what I recall, I think that's what I saw. So you want to take images. Since we started kind of after the early phases of the umbral eclipse started, you might want to stick around to the end so you can at least get some of those images. You don't
Yeah,
have to use all the slots. Usually your
yeah,
favorite image goes right in the center, which I would choose the moment of totality, where we've got that beautiful color that can kind of go in the center, and then you can put as many that you want around it. It's just a great way to learn by doing, learning about the telescopes,
yeah.
learning about the event, learning about the objects. This one is about the moon, but we have them on pretty much every other type of object that we have available on Slooh. So there's plenty to learn, and it's painless to do it. They're a lot of fun.
They are. They are. And, there's so many moon-related quests. We were talking today about, the phases of an eclipse, which occurs just over these few hours. But then we've got the phases of the moon quest. We've got an Apollo missions quest as well, haven't we? Oh, there we go. Look at that. You were prepared, Keith. So what other lunar-related quests have we got? There's a lot. Wow.
Well, here on Slooh, we love the moon. In fact, one of our student members over on Discord refers to herself as being a selenophile. So I think we all suffer from selenophilia to a very large degree. We're in the advanced stages. That means that we love the moon. There's everything on here, depending on your age group and your level of knowledge and understanding. There's something for everybody, from the middle schooler to the elementary school, all the way up to college students and people using some advanced techniques. Lunar phases, you've got to know what the lunar phases are if you haven't done that
Yep.
already. That would be the first one I take. Lunar features, we talked a little bit about that. We didn't have a close enough view really with the eclipse to see some of the stuff that we see. Another must take, I would say, after you finish your eclipse quest, you've got to take these two. These are two
Yep.
must know things: lunar features, lunar phasers. The Apollo missions, you mentioned that. You can use the Slooh telescopes to identify the lunar landing sites. 7 landing sites. There was Apollo 13 that didn't make it to the moon. Not a tragedy. You can learn about that too in the quest. But you can actually stick a little pin in the lunar map that we find on Slooh of where these landing sites are. And of course, Milton's marvelous quest, the Mauna
Yeah.
Kea Inca Moon quest, which he talked about a little bit. One of the heritage quests that talk about how native indigenous peoples saw other events that happened that we see. So
Yeah. I love that particular poster, by the way, by a student, because they've captured the solar eclipse. They've captured the new moon at the moment of the solar eclipse on one of our events. And of
yeah,
course, that's the only
exactly
time
right.
that we actually see the new moon, isn't it, Keith?
That's it. Solar eclipse is the time. Total solar eclipse is the time that we see the new moon. Pretty much the only time. And there it is. There. The neat thing about the new moon, solar eclipse moon, is that that's the same moon that we see at full moon. It's just not illumined and passing in front of the sun. So we see it here. It's a great, great image. That person
Yeah.
could go one step further, I think, and stick in the eclipsed moon into the full moon spot if you wanted to.
Oh, exactly. Hey, listen, if Milton's around, let's spend just a few minutes to wrap up the star party. Keith, first of all, tell us what you're making of this. Tell us what we're seeing for those people who maybe joined us a little bit late.
We are looking at the moon finishing up its passage through the dark inner umbral shadow cast by the Earth. It will start to gradually move out, so we will see the lightning on the limb of wherever it starts to move away from that dark shadow. It looks great. It's the full moon, totally eclipsed by, or passing into the shadow cast by the Earth, reflecting all that beautiful red-orange light of the
Exactly.
sun. So
So
beautiful.
Yatni is still here from Indonesia, and Milton can come in as well if you like. Let's just hear their summary of. I'm interested actually to hear from Yatni because hopefully she's been able to go outside and actually witness this with her own eyes. Unfortunately, here in the UK, the moon hasn't risen yet, so I'm not going to be fortunate enough. But if Milton or Yatni are there, then please join us.
Yeah. Here.
Hello, Paul.
Hi, Yatni.
Ah,
Yatni? Have you managed to get out and see much of the eclipse with your own eyes?
yes. I'm outside now. It's a bit cloudy here, but the moon is still good to observe now.
Excellent. So I don't know about you, but Keith and I often say this, that we quite like, and we can see it actually in your live feed now, we quite
Mm.
like a little bit of cloud passing during
Mhm.
solar and lunar eclipses because it gives a depth, doesn't it, to the view.
Yeah, it's because the image is quite still, and when the cloud is passing, and people feels it's it's a live image of of the phenomena.
So we said at the beginning that sometimes with the color of the moon during a total lunar eclipse can be affected quite a lot by the type of equipment that you're using. How
Mhm,
accurately would you say the visual view is that you've got at the moment
mhm.
to the color
Well,
that we're seeing in
mhm.
the live feed?
It's a bit brighter than what I've seen with my eyes now. But the color is it's pretty much the same with what we
Right.
see on the screen.
And how would you describe the color? Because I often think
Mhm.
of an eclipse moon as being more of a peach color than anything else. But how would you perceive that?
I think it's like a Karas iron with the
Yeah.
oranges like that. Mm,
Yeah, yeah, I can see that. A kind of
mhm.
rusty iron,
Yeah.
especially on the right-hand side where it's darkest. But we're seeing this,
Mhm.
brightening. Now, sometimes a camera can, in fact, it looks incredibly like Mars at the moment, but sometimes
Yeah.
a camera can give greater contrast than you can
Mhm.
see visually. Can you see the that kind of graduation across the surface of the moon with your eyes?
Um, yes, I think. Although there are some part of the moon that cover with the clouds, but the gradual color is still visible.
It's
Uh,
still there.
quite nice.
So, how has this lunar eclipse for you been in comparison to other lunar eclipses that you've seen?
Well, every eclipse is different, of course.
Yeah,
And I think it's quite special because we have, uh, from the beginning, we have a clear sky, so the moon it's visible very good with our even with our eyes. So yeah,
excellent.
I think having observed the moon with our own eyes and also the telescope is giving very quite an experience for me
And
personally.
and you're very well placed in Indonesia for this particular
Mhm,
eclipse because the moon
mhm,
at midway at its fullest phase it was
mhm.
still quite high in the sky, isn't it?
Yeah, it's right above my head right now. It's a bit to the west now, but yeah, when the
Excellent.
totally phase, it's right above my head.
That sounds like perfect
Mhm.
placement for me because I have seen, here in the UK, the moon is actually going to be rising just in its
Mm.
last moments of
I see.
eclipse, so it does depend on where you are around the world. But I heard
Yeah.
something like there's because of where this is visible, primarily over Asia and then certainly Eastern Europe, there's something like 7 billion people who are able to witness this if they've got, of course, clear skies like you've got.
Wow. Yeah, that is quite a number.
Yeah, it's a crazy number. And,
Mhm,
that's the lovely thing I always think about a lunar eclipse. And that is, if you can see the moon during the eclipse, you see it. It's not like a total solar eclipse where you have to be in that very narrow
mhm,
path, usually 70 miles wide or something like that. But I love this view that you're giving us now
mhm.
with that cloud passing. Yatni, I hope you've enjoyed helping us out with this. We greatly appreciate it. And I'm so glad that you've got to see it with your
Yeah.
own eyes outside. So thank you very much.
Thank you for having us.
Take care.
Thank you,
Milton,
Yasmin.
Milton, what's
Yeah.
what's what's your view of this particular lunar eclipse in comparison to others that you've seen?
Well, it's still early here in South America. It's 2:30 p.m. We will have definitely a beautiful full moon tonight, and we've been having clear skies, so I expect a beautiful view of the moon. We're gonna miss the total eclipse around here, I guess, but we will definitely be chasing for the next one. Now,
Exactly.
I
That's
agree with Yatni.
yeah,
Every eclipse is different.
it is, and we always know there's going to be another one, albeit
Exactly.
as we get older, a diminishing number. But unfortunately, living in the UK, so many eclipses have been spoiled by weather. And that can be. I kind of feel really badly for Rick tonight at the Gravity Discovery Center because, you know, it's going on behind the clouds, but you can't see it. So
Something that astronomy teaches is patience and resilience.
it
We
does.
will go for the next one, of course, but yeah, it's a very humbling area of study.
It is. I totally agree with you, Milton. Thank you very much for those passing shots. We'll go back to Keith for any final words from him before we wind up the hosted part of the Star Party. We are going to keep the feeds up so you can carry on capturing images. But Keith, any final words for us?
I think just enjoy the event, and like I said, like you just said, if you haven't had enough fun yet, we're going to watch the feed until the final phase is over, until we move out of the umbral shadow into the penumbral shadow. So
Yeah,
we've got a lot.
we seem
Yeah,
to
we've
be.
got a lot of moon left.
Yeah, we seem to be moving into the cloudy part now, though. But thank heavens, we've had total clear skies all the way from the beginning of the eclipse from Indonesia, all the way through maximum, and it's only now just starting. But I don't know about you, Keith, but I actually really enjoy watching some passing clouds going through like that.
That's good. Even better is when we have an airplane transit, when you see something
Oh,
fly across, or a bird. Those are great too.
I think I see one shared in the Slooh Discord server that somebody had caught. I think was it one of Gretchen's that she caught either a bird or a plane going in front
Gretchen's
of
had
the
two
sun and
planes,
moon. Two
so you have to go.
planes.
Yeah, you have to go back, watch the live feed, and take a screenshot. So.
Wow. I can remember we did a lunar eclipse with feed partners in the Middle East, in the United Arab Emirates, and suddenly we saw this enormous jumbo jet go straight in front of the eclipse moon, and then you saw the contrails behind it. It was the most amazing sight. Unfortunately, I didn't capture an image of it, but Keith, thank you so much for sharing your expertise and enthusiasm for the subject in hand tonight. I've learned a lot. I always learn a huge amount from you. So thank you so much for joining us.
My pleasure. Thank you for having me.
Well, it is time to end this hosted bit of the Star Party. I would like to thank our special guests. We've had Keith Milton, Rick Tonello from the Gravity Discovery Center, and Yatni Uliati from the Bosca. I can pronounce it correctly now. The Observatorium Bosca at the Institute of Technology, Bandung, Indonesia. Rick, unfortunately, was clouded out down in Australia. We have had some pretty cool images from the Slooh Observatory on the east coast near Siding Spring, Australia. We also saw very briefly earlier, I think it was actually before the show, our friends over at the Astronomical Society of India. They were struggling with some pretty poor weather down there as well. So Indonesia really has helped us out here. I don't know, Gretchen, did we manage to get any images from Jari Backman, a longtime member from Finland?
No, we didn't. The position of the moon, it
Oh.
was close to the horizon, and then he couldn't get a clear shot for us. So
Oh, what a shame. But Yari, thank you so much because I know that you've already done loads of prep for it. And there really is such a huge amount of preparation for all of our feed partners. And it is gut-wrenching when you're clouded out after all of that preparation. But I've just mentioned her. Massive thanks for our event and community manager today, Gretchen Bickert. These events would not be possible without your amazing work. So thank you very much, Gretchen. Now, we've got loads coming up at Slooh over the coming weeks. So keep an eye on our social channels and website. Don't forget, we got those new starter accounts that are launching on September 15th, particularly suited to teachers and homeschoolers who only teach space or earth science for a single unit or a single semester. And to all of the students watching, make sure you enter the Falling for the Moon contest. The deadline for that is October 21st. I did notice a small typo in that earlier, so that will be corrected. That wasn't you, Gretchen, I know. But anyway, the Falling for the Moon contest. Maybe use some of your blood moon lunar eclipse images for your poster submission there. Now, we've also got some other star parties coming up on the horizon. We got a members-only star party to celebrate the September equinox. Those are always great fun because we have live feeds from Slooh's specialist solar telescope at our flagship observatory at the Institute of Astrophysics of the Canary Islands. So that's perched on top of a volcano at 8,000 feet, 2,000 meters above sea level. And then we've got a public star party in November to celebrate the largest supermoon of the year. There's 3 in a row, but we don't think that you can have 3 super things in a row. So we only go for the biggest supermoon of the year. So that's in November. Those are always great fun as well. So please join us for that one. But that's it for now. Until next time, clear skies, everyone. And thanks to everybody who was involved in pulling this epic and exciting and awe-inspiring, frankly, event together this evening. Take care, everyone. Bye now.